All right, guys, we're ready. We're ready. Here we go. So this is Notes 9.5. Notes 10 will be chain rule. And now we're just going to start. We're starting to see little applications here and there. So look at question 5. Oh, that's awesome. Come on, buddy. All right, so here we go. So on the first questions, guys, the first 4, they just want derivative. Now, just because there is a quotient doesn't mean you have to use quotient rule. You can, but you'd be like wasting your, well, I don't want to say wasting your time. You'd be making it harder for yourself. So you'll see when we get there. Question 1 is straight out just power rule. You can write y prime or you can write dy dx, it doesn't matter. Y prime equals the derivative of 4x to the negative 2 is minus, and if they don't tell you anything, you can leave it alone. If they tell you all positive exponents, well then you write them with all positive exponents. If this were a multiple choice, I'm pretty sure you wouldn't see this answer. You'd probably have to do a little bit of algebra. Cool? Now on question 2, just because you see a quotient here, x cubed over 3, doesn't mean you have to do quotient rule. You could if you wanted to, but I think you're just making life harder for yourself. Rewrite this so you can see it a lot easier. 1/3 x cubed minus x. Do you guys see that? And then when you take your derivative, y prime, 1/3 times 3, 1. And then subtract 1 from that x cubed, that's going to be x squared minus, what's the derivative of x? 1. Now, if you were to do quotient rule, don't write this down, just listen. You would get the right answer. Bottom, 3 times the derivative of the top, 3x squared minus top, x cubed times the derivative of the bottom, 0. And then minus, all this over bottom squared, minus 1. And look, you do get the right answer. That cancels out. One of these 3's cancels out with one of those 3's. The other 3 cancels out with that 3. And look at that. Y prime equals x squared minus 1. You do get the right answer, but look at how much work you have to do. Do you guys see that? So just because, so look at question 3. Just because it's a quotient doesn't mean that you should do quotient rule. You can. Y prime. Don't write this down, just listen so you can see it's going to be the same. Bottom times the derivative of the top minus top times the derivative of the bottom over bottom squared. So let's see, that zeroes out. You get a negative 1 over x squared. So that's my derivative. I did quotient rule, right? But if you would have done this, if you would have just brought that x up, x to the negative 1, look how much faster it is. Now this one you can write negative 1, x to the negative 2. And if you want to have it positive exponents, look at how fast that is. What's up?
I'm sorry, what's the title?
Integration, partial fraction integration. You'll see like PFC maybe or something like that. Do you see it?
PFD?
Yeah, PFD, partial fraction decomposition. Sorry, they're doing integration. Are we cool or are we not cool, guys? Okay, so now you see, you don't have to do, just because it's a quotient, you don't have to do quotient rule. So here it is, question number 4. Rewrite this as x to the power half. That's actually the recommended way to do it. And then when you take a derivative, y prime equals 1/2 x to the negative half. And then I would just rewrite it 1 over 2 square root of x. Make sure you're using correct notation. Some of you guys, I was looking at your circuits, some of you guys aren't telling me derivative. You're just going right into it. If you're telling me a derivative, write y prime. And then some of you guys are writing your derivative but not writing anything on the left. Like, what is this? Like, you just put that and then equals blah. Like, you got to tell me it's a derivative, y prime. And then some of you guys are writing the derivative immediately from y. Some of you guys are doing this. Why is that wrong? Yeah, this is called, there's a specific word that AP calls this. They call a linkage error. This is called a linkage error. You're linking all of them together when they're not the same. This one is, that's the same as square root of x, but then you're finding the derivative. So you cannot put an equal sign immediately after that. You got to start a new line and say y prime or something, that it's a derivative. That makes sense, guys? Okay. Now check it out. I put this question in here on purpose for some of you science people. Isn't that a cool question? Let's read it. If gas in a cylinder is maintained at a constant temperature T, the pressure P is related to the volume V by a formula of the form P equals nRT over V minus NB minus AN squared over V squared, in which A, B, N, and R are constants.
I'm intimidated.
Isn't this cool? This is something that like maybe someone that's doing research in PV equals nRT or something. Do you guys remember covering this in chemistry? Yeah, the ideal gas law. So this is the ideal gas law with, I guess, maybe steroids, if you want to call it that. So look, they're finding the difference in pressure with respect to volume. You guys don't think this is cool? All right, here we go.
I'm just a little bit scared.
No, look. First, identify what is constant. A, B, N, R, and as well as T. Yeah, everything except V. So it makes it easy for us to take a derivative. Well, later on we'll take derivative of several things changing, but right now we're rookies. So here we go. I'm taking the derivative with respect to what letter? V, and everything else is a constant. So here we go. dP dV is equal to what rule? I guess this one we're going to use quotient rule. Because, I mean, it doesn't make sense. Well, I mean, I guess you could. Okay, so here we go. Bottom, V minus NB times derivative of the top. What's the derivative of nRT if they're all constants? 0. Minus top, nRT times derivative of the bottom. What's the derivative of V minus NB? With respect to V. 1. The V is like an X. All over bottom squared. Minus, if you want to use Paul rule here, you can, but I'm going to go ahead and stick with quotient rule. Bottom. Are we still okay? Times derivative of the top. 0, right? Minus top times derivative of the bottom. What's the derivative of V squared with respect to V? 2V. All over bottom squared. Do you see what we did there? And now we're just going to do math, just basic algebra here. So let's see, that cancels out. And then, so let's see what I have. dP dV. Well, anything times 0, it zeroes out. And I have negative nRT over V minus NB squared. And let's see, that zeroes out. Negative times a negative is a positive 2VAN squared over V to the fourth. How many V's can I cancel out here? One of them. So here's my final answer. 2AN squared over V cubed minus nRT over V minus NB squared. I like to have positive terms in the front. And if you're... Yes. If you're someone in chemistry doing some type of research, maybe this formula would be useful for you because you're doing something with pressure and volume and you want to see how they're related. And here it is, dP dV. Your rate of change of pressure with respect to volume. Cool, right? This only applies if the temperature is constant. Oh, awesome. Thank you, Ms. Harris. Oh, look, we're doing chemistry. Ideal gas law. How do we feel, guys? So hopefully you feel that you're getting an awesome, not only math, but science education because, look, we're doing science. Cool? Cool. Well, really, science is math, right? All right, here we go. You guys ready? Here we go. Question 6. See if you guys can get ahead of me in some of these questions. Question 6. Y prime equals... What's the derivative of 1? 0. What's the derivative of x? 1. And then I have minus. What's the derivative of cosine? Another. So it's going to turn into a... There it is. Can we do that? Number 7, what I would do first on number 7 is bring that x up. So I haven't done anything. I'm still at y equals x to the negative 1 plus 5 sine x. You guys ready? All right. Y prime. The derivative of x to the negative 1 is negative 1 x to the negative 2. And the derivative of 5 sine x is? Okay, there's a question. Do I have to do product rule with 5 sine x? I could if I wanted to, but do I have to? So I can just go plus what? And we're going to talk about why, don't worry. So, how do you determine when and when not? Okay. All right, so let's have a discussion. So here's my derivative. Let me simplify it real quick. 1 over x squared plus 5 cosine x. So when do we do product rule? When do we not do product rule? And why did we not do product rule with the 5 sine x? So let's focus on 5 sine x. Let's say we did. So let's say we just, I'm just making this up, and I'm writing 5 sine x. And let's say we put the 5 by itself and the sine x by itself, like that. All right, let's see. Remember that rule that we talked? Okay, don't worry, I'm going to bring it back. So if we did product rule, we would have gone first times the root of the second plus the second times the root of the first. And notice that this right here zeroes out. Now, remember, Miss Taylor, when we were having a discussion about, we were writing d dx, and you were saying, I think we had like 5x squared, and I was writing it like this first, 5 times 2x, and then you were like, can't you just multiply the 5 by 2 because that's how it always does? And then I was like, well, yes, but in the future when we have something like this, like I want to see, this is the future. So notice the derivative of 5x squared, we just got 10x, right? It's the same logic with this here, guys. Well, why did we not use product rule? We can. Look, we just used product rule and we got 5 cosine x. Because we have a constant in front of our cosine. So it's like that, guys, focus. So it's like that 5 cosine x's or 5 sine x's all together. Does that make sense? Yeah. Now, as soon as I put a variable in it, as soon as I do this, now I must use product rule. Do you guys see the difference? Yeah. So as soon as you have a variable in front of that dude, 5x or 5x squared, whatever it is, then you must do product.
So if you had 5x, would 5x be the first term? Or would it be?
Yeah, 5x would be the first term.
So then how do you know, like, remember we would use the brackets?
Oh, that's when you have like a minus and you're like, where does the minus go? Just put minus bracket and work with that world and distribute the negative. Okay. It's just algebra. Yeah. Okay. Are we okay? Are we more legit now? Yeah. All right, here we go. So here comes your question, Rubio. So if this minus freaks you out, if you're like, I don't know where to pair it, I don't know what to do with it, then work with it on its own little world. Do this. Look, I'm just putting brackets. Do you guys see what I did there? And then distribute that minus later on. So here we go. Y prime equals, the derivative of 4 is just 0. There's my negative, and here comes my bracket. And then I just work with the brackets. What rule do I got to use here? Product. First, x squared times the derivative of the second. What's the derivative of sine x? Plus second times the derivative of the first, which is what? And there it is. And then just distribute that negative that you have on the outside. So y prime is equal to negative x squared cosine x minus 2x sine x. Usually you want to bring the numbers to the front of your trig. Yes.
When you do the product rule, because it's adding, does the order in which you solve it matter?
No. That's why delta does it the other way around.
Yeah, that's how I looked at delta and I started doing it like that.
That's fine. That's fine. There's always, that's fine. You know why delta does it that way, right? Because it makes the quotient rule easier to memorize, but it's the same thing, but instead of a plus, it's a minus for quotient. So it's fine. It doesn't matter the order because it's plus. But I'm going to stick to my habit. So, are we okay, guys? Okay. Number 9.
Wait,
What's up?
So you can't simplify that one anymore.
I mean, you can factor out an x, but I don't think. I mean, I would leave it. Number 9, guys, you could do quotient rule, and you would get the right answer. But immediately I see this. If I see a constant in the top, I'm tempted to just write it as, what can I rewrite this as? We all took pre-calc, right? So I have a cosine x on the bottom. I can rewrite this as 4, not sine. I can write that as 4 secant x.
Because it would be like 4 over 1 times whatever cosine and whatever cosine.
So here we go. Y prime. What's the derivative of secant x? Secant x tan x. There's a 4 in the front, so keep it. 4 secant x tan x.
Oh yeah, that's when I'm right. We're basically gonna stand
Wait, that's okay. Do you have to? So why do they go through this derivative of? I understand. Like, I don't understand. Why is it just 0?
Well, because I'm not doing product rule or quotient rule. We could do quotient. We'll get the same answer. Y prime. Look, don't write anything down. Just listen.
Like I understand what we just did and all that. What I'm
Oh,
saying
it's
is, like the same thing is up there. Yeah, exactly.
It's
In
this.
that scenario, yeah, in that scenario, why don't you have to do the derivative of the constant? Because the derivative of the constant is 0. Right?
because the derivative of a constant is 0. If you wanted to do product rule, you would still get the same answer, but you can leave the 4 alone, and then just take the derivative of secant x, which is secant x tan x. Like what I did here. See, leave the 5 alone, and then do the derivative of the x squared, which is just 2x. So no, because it's tied together with secant x. It's 4 secant x. So now if 4 had a variable next to it, if it was 4x, we do have to do product rule. Does that make sense? Okay. Martinez, you good? Rubio, you good? Harry Styles, you good? Oh wait, he's not here.
He's real good, sir.
Stop. All right, here we go. Number 10. Number 10. Number 10, guys. Here we go. What rule do I got to do for number 10? Quotient. There's no other way. You got to do quotient. Bottom. Times derivative of the top. Ooh. Okay. So relax. You slow down and you're like, well, cotangent is similar to tangent. Yes or no? Do you know the derivative of tangent?
Yes.
What was the derivative of tan? Secant squared x. But I don't have tan. I have cotangent. So the derivative of cotangent must be negative what? Cosecant squared x. Do you see how we got it? You don't have to use a lot of brain power, guys. You just got to know derivative of secant and derivative of tan. Minus, a little bit of brain power. Minus top, bottom times derivative of the top, minus top, times derivative of the bottom. Again, the derivative of the bottom is going to be over bottom squared. Bottom times derivative of the top minus top times derivative of the bottom. Low D high minus high D low over low low. Are we okay so far, guys? I'm kind of tempted to do something to the numerator, but I don't know if I want to. All right, guys, focus, guys. Shh. I'm gonna leave it. What's up? No, ask. I don't see the 1 plus cotangent canceling out. There's no square on it. I don't have another 1 plus cotangent. You can't. There's only one right here. You need to have another one. No. Okay, you got to have this. We have this. AB minus C D over A. So you only have one A there. Oh, A squared, I guess. So you can't cancel out one of these A's. See, 1 plus cotangent. I need to have another 1 plus cotangent here for me to cancel one of them out.
Or would it have to be like AB in the bottom? Because you're
'Cause,
subtracting the numerator, you're not multiplying.
Well, because I can't. I need to have a common factor of 1 plus cotangent x on both of the products. Does that make sense, Parker? Yeah. So I can't cancel it. Now there is something. I do see something that I can possibly do, and I do see that it might reduce, but I'm gonna leave it alone because we don't have multiple choice right now. Are we okay right now, guys?
Just leave it like that.
For now, yeah. If it were multiple choice and we don't have that answer, then we're gonna have to do something. All right, here we go, guys. This one says NC. Whenever you see the letters NC, it stands for no calculator. So here we go. They want me to draw a tangent line and a normal line for this graph at x equals pi. So for a tangent line, I need two things. What and what? Point and slope. So let's find my point. Pi, comma, let's see, y equals sine pi plus 3. What's sine pi? Sine 0. So pi comma 3 is your point. Are we okay so far? Now I need to take a derivative so I can find my slope. So here we go. Y prime equals the derivative of sine x. Cosine x, the derivative of 3 is 0, so there it is. I'm going to plug in pi. What's cosine of pi? Yeah. -1. Unit circle quizzes are coming back, guys. Yeah.
I promise
No.
I know all of that. I'm just still writing number 10. So.
Yeah. No, but they got to come back because I can see some of y'all's faces. Don't worry, we're good. We're good. Here we go. Point slope form. Y minus 3 equals slope, -1, x minus pi. If you are prone to accidents, I would leave it alone. Call that tangent. They want the normal. What's up?
Okay, so I don't understand why we use the derivative.
Derivative means instantaneous rate of change.
That's
Are we okay right now, guys? Yes, miss. Cosine of pi is -1. Up. Y at the top, is it equal to 2?
So like why does it say y equals sine of pi plus 3 is 0?
0 plus 3 is 3, no?
Yeah. Oh.
Any other questions, guys? All right.
I'm still going to recommend the cosine of pi because I thought we already had our case.
Well, we got our point, pi 3, but then I needed a slope. And to get my slope, I got to take a derivative.
Yeah, and then I thought we already had the derivative with cosine x.
Yeah, that's just a derivative. Now I got to plug in the pi to see what the value is of that derivative. And that gives me my slope. All right, here we go. Sorry, there's a fly here. The normal line. How do I get my normal line? Opposite reciprocal. Since I have -1, my opposite reciprocal is just going to be 1. So write the same thing. I guess you don't technically need parentheses. And I want to see a picture of this, so I'm going to go ahead and use Desmos really quick so you guys can see. Let's see, sine x plus 3. So everyone knows how sine x plus 3 looks like. It's just a sinusoid curve with the vertical shift 3 up. So here we go. Y equals, don't worry, it's coming back. It's just that it's getting really warm here. Sine x plus 3. And it wanted to see my tangent slope at pi. So what was my equation? Y minus 3 equals -1 x minus pi. And yeah, that looks tangent. And let's look to see our normal here. Y minus 3 equals, x minus pi, yeah. X minus pi. And yeah, that looks normal for sure. Look at that. Cool or not cool? Cool. Yeah, that looks... Alright, let's go to the next one. Okay, now I notice that I have multiple choice. So it looks like I'm definitely going to have to do properties on this one. So here we go. What rule do I got to... Well, first let's read the question, right? Which of the following defines the instantaneous rate of change of the function with respect to t? So as soon as you see instantaneous rate of change, they're asking you to find the derivative. So I'm going to find a derivative. What rule do I got to use? Quotient. So f prime of t is equal to... Now you guys tell me, what do I write first? Okay, put that in parentheses. Times, derivative of the top, which is cos t. So bottom times derivative of the top, minus sine t times yeah, you're right. All over I don't see any mistakes. Let me check. Bottom times derivative of the top minus top times derivative of the bottom. Derivative of sine is cosine t. Derivative of cosine is negative sine t, but negative times a negative is a positive. I see everything correct. Now you look at your answer choices. You don't have that. So that means we're going to have to do some simplification. So I'm going to distribute the cosine t, and I'm going to distribute the sine t. So here we go, guys. We're going to get, I'm going to write equal sign. I'm going to write sine t cosine t minus cosine squared t minus sine t cosine t minus sine squared t all over sine t minus cosine t squared. I don't see any mistakes initially. Let me check. Minus. Okay. What's going to... Oh, wait. Yeah, what's going to zero out? Sine t cosine t zeroes out. And then I guess I'll write this really fast. Negative cosine squared t minus sine squared t over sine t minus cosine t. All that is still squared. And then I look at to my left and I look and I still don't see that answer choice in there. What else can I do? If you factor out a negative, you're going to have the Valentine's formula on the top. So here we go. Notice you got cosine squared plus sine squared, which is what? That's 1. So finally, negative 1 over sine t minus cosine t squared. And that answer, I think I did see that. There it is. How do we feel? Awesome. Number 14. Oh no, it's a limit. Perfect. That's the key. You can actually solve this if you wanted to. You can use your composite argument properties from pre-cal. Because we did it. It's like in our notes at least 3 times. It's on a UH quiz. It's on one of the notes. The first time we did it sloppy. Then we did it again on the notes where we were like, oh, we did it sloppy. Let's do it again. And we did it again, but nice and clean. So it's in our notes at least 3 times. You could do it again for a 4th time if you wanted to. Do you have to? No. Recognize that this is just derivative. Derivative of what function? Cosine x. What's the derivative of cosine x? So look for negative sine x. Do you see how we did it, guys? Yes, Ms. Parker. Oh, because it looks like this. Limit as h approaches 0 of f of x plus h minus f of x over h. Yes. Cool or not cool? Cool. Look at number 15, guys. Is number 15 another one of those? Yes, you could, if you wanted to, you could multiply by the conjugate and all that good stuff. But looking at number 15, what's f of x on this one, Miss Parker? Perfect. This is just the square root of x. Can I take the derivative of that really fast? Yeah, let me rewrite it. X to the 1/2. So here we go. F prime of x is equal to 1/2 x to the negative half. Let's rewrite that. 1 over 2 square root of x. Do you see how we did it, guys? All right. Is this the last one? We've got 2 left. Number 16. Whenever you're dividing by one single term, you call that 2x one term, right? You can choose to either break it up into 2 terms, or you can use quotient rule. It doesn't matter. They're both going to be the same. I want a tangent line, so I need 2 things. I need what and what? Point and slope. So let's find my point. 1 comma, let's see, 1 plus 1 is 2. 2 divided by 2. It looks like 1 comma 1, but I make mistakes all the time. All I did was this. 1 plus 1 over 2 times 1. Yeah, it's 1. Are we okay? What route do you guys want to do? Quotient rule? Doesn't matter. Okay, here we go. Yeah, it really doesn't matter on this one. So quotient rule. Bottom, 2x times the derivative of the top, plus or minus? Minus top times the derivative of the bottom, all over 2x and the whole shebang squared. And here we go. Now we're just going to plug in the value that we want. We want the slope at 1. So let's see. You could, I guess you could, but I'm already just plugging it in. 2 times 3 minus 2 times 2 over 2 squared. What is that? 6 minus 4 over 4. So 2 fourths. So I got a half. Is that what you guys got? And here we go, guys. Here's my tangent line. Y minus 1 equals half x minus 1. Do you guys want to see the curve and the tangent? Yeah? Sorry, guys. There's a fly here. Yeah, let's see it. Clear, clear, clear. What was that curve again? Y equals what? X cubed plus 1 over what? Oh, that's going to be a cool graph. Look at that. And then what was my tangent? Y minus 1. Look at that, guys. That looks pretty cool. That 100% looks like a tangent. Cool, right?
That's a very fun graph. I like the,
Yeah.
the side where it goes out.
Yeah, I really like. Imagine what Leibniz and Newton's could have done with all this processing power. They didn't have all this stuff here. I think it's awesome. All right, guys, give number 17 a shot. See if you guys can get an answer, and then we'll talk about it in about 2 minutes. Do we have a volunteer that wants to come on up? And you're going to explain it to us, right? Okay, Ms. Parker's going to explain it to us. You'll be featured on YouTube.
Okay, so I saw this and I used the quotient rule, and I always have to write it out on the sides. That's what these letters mean. I can put my arm on it. So wait, how did I write it?
It's bottom times right of the top. So
Oops.
B, there you go.
Oh, I think that's what I meant. Okay.
I feel like you should use different letters other than you and me.
Yeah, because they look.
The V and G. F and G, yeah, we probably should have used F and G. No big deal.
Because you and me look so similar that
Oh, nope, no, no. That'd be. No, that's you. Oops.
Good job.